Good morning, dear students. We were talking about some important chemical reactions of P block elements. There we have seen the hydrolysis reaction of xenon fluorine compounds. Then we have seen disproportionation reaction of Cl2 in presence of sodium hydroxide. Then we have talked about compound ammonia NH3 and its some important properties. Today we will talk about two more important compounds of this chapter, that is SO2 sulphur dioxide, and second one is your hydrogen chloride, SO2 and HCl. So if we check the oxidation state of sulphur in SO2, then the oxidation state of sulphur here is +4. We know it very well that sulphur exhibits maximum oxidation state of +6. Sulphur, which is exhibiting oxidation state of +4 in SO2, can be converted to a compound where sulphur exhibits oxidation state of +6. This change in oxidation state is possible for sulphur. So when sulphur will make a change in oxidation state from +4 to +6, means it is increasing its oxidation state, and this will take place by losing of electron. And if a substance loses electrons, then this is called oxidation. The substance which are showing oxidation can act as reducing agent. So remember here, in presence of moisture, sulphur dioxide will start behaving as a reducing agent. Water is required, moisture is required, because transfer of electron requires some medium. So about the first point is method of preparation, that is lab method. How it is prepared in laboratory. So it's very simple. Any sulfite salt, sulfite ion, SO3 -2 ion. Any salt which contains SO3 -2 ion, that is sulfite ion, when treated with acid, then this acid has the property to decompose sulfite salt, as a result of which SO2 gas is produced with the formation of H2O also. Because water is formed in the chemical reaction, SO2 is a gas, so you will observe formation of bubbles in the beaker where you have taken sulfite salt with acid. So whenever sulfite salts are taken with acid in a beaker, then you will observe formation of bubbles due to formation of SO2 gas. Then we have industrial method. On large scale, how it is prepared, that is your industrial method. So on large scale, it is prepared by roasting of sulfide ore. Roasting. It's not a new term. There are two terms, calcination and roasting. When ore is heated in absence of oxygen, it is called calcination. When ore is heated in presence of oxygen, this is called roasting. So when sulfide ores are roasted, or when sulfide ore undergoes roasting, then it is formed as a byproduct. SO2 gas is formed as a byproduct. Here we have taken iron sulfide. On roasting forms Fe2O3, that is hematite, and sulfur dioxide is formed as a byproduct. Then comes the properties. SO3 gas is highly soluble in water. As I have told earlier, the gases which can undergo chemical combination with water are generally more soluble in water when compared to the gases which are not forming compound with water. SO3 reacts with water and forms H2SO3, that is your sulfurous acid. So there is a chemical reaction between sulfur dioxide and water. That's why the gas is highly soluble in water. Next one, SO2 when made to react with Cl2 in presence of charcoal. C stands for charcoal, an allotrope of carbon. Then by reaction, it gets converted to SO2Cl2, which is called sulfuryl chloride. Remember, SO2Cl2 is sulfuryl chloride, while SoCl2 is called thionyl chloride. Next one is the oxidation of SO2. SO2 when made to react with O2 in presence of vanadium pentoxide as a catalyst. What we call it is that divanadium pentoxide. SO2 undergoes oxidation, as a result of which we get SO3 gas. This is the most important step involved in contact process by which sulfuric acid is formed. This is one of the important steps of contact process. Oxidation of SO2 to form SO3 in presence of divanadium pentoxide as a catalyst. Then, when moist, sulfur dioxide behaves as a reducing agent. Means it can carry out reduction for other substance. It can convert Fe+3 ions to Fe+2 ion. The salts in which Fe+3 ion is present will be converted to ferrous salt. And it reduces MnO4- to Mn+2 ion. In the same manner, Fe+2 reduces MnO4- to Mn+2 ion. MnO4- is a violet color compound. What happens? MnO4- is converted to Mn+2 ion. It is a colorless ion. So here, when SO2 gas is passed through potassium permanganate solution, acidified potassium permanganate solution, then it will lose its color. So if a gas can decolorize acidified potassium dichromate solution, then it is SO2 gas. So this redox reaction can be a convenient test for SO2 gas. Then about the structure, SO2 is a resonance hybrid of two structure, where one oxygen is forming double bond with sulfur, and there is a coordinate covalent bond between the next SO bond. In resonance, there will be change in the position of double bond and the coordinate covalent bond. Here it will be S coordinate bond with O, S double bond O. So here we can say that both the SO bonds are identical in nature. The bond length for both SO bond will be same because it is resonance. It is showing resonance. So we will obtain resonance hybrid. So in SO2 molecule, both SO bonds have same bonding parameters, same bond length. Then we have hydrogen chloride. It was first prepared by Glover when he has heated common salt with concentrated H2SO4. NaCl was heated by H2SO4, a type of double displacement reaction as a result of which HCl gas was produced. So the same reaction can be used as a lab method for the preparation of HCl. So lab method, by heating sodium chloride with concentrated H2SO4. So NaCl when heated with H2SO4 forms sodium hydrogen sulfate with HCl. And this salt with NaCl again forms Na2SO4 with the release of HCl gas. So reaction gets completed in two steps. About the properties, it is a colorless and pungent smelling gas. It's not pleasant, pungent. There is no color. It is extremely soluble in water as iodine is below. HCl when gas, it is called hydrogen chloride. When it is dissolved in water, then it is called hydrochloric acid. Because in gas form, it will not form H plus ion. But in presence of water, HCl undergoes ionization as a result of which we obtain H plus ion. So when HCl gas, it is hydrogen chloride, and when HCl aqueous, it is called hydrochloric acid. It's highly soluble in water. Reason, HCl with water undergoes ionization and we obtain H3O plus and Cl minus, H3O plus ion. It shows the acidic character, it's H plus ion. Then it reacts with NH3 and gives white fumes of NH4Cl. NH3 is a Lewis base. So this HCl reacts with NH3 and form NH4Cl. Due to formation of NH4Cl, we obtain dense white fumes. Dense white fumes. And when taken with HNO3 in 3:1 ratio, 3 part of concentrated HCl and 1 part of concentrated HNO3. This is called aquaresia. This mixture is very important because it can dissolve noble metals like gold, silver and platinum. No other acids can dissolve gold, silver and platinum. But aquaresia, where 3 part of concentrated HCl is there and 1 part of concentrated HNO3 is there, can dissolve these noble metals, because these noble metals can form salt with this mixture, with aquaresia. That's why these noble metals are soluble in aquaresia. That's all for today. Thank you and have a good day.